Welcome to the Energy System Modeling course. My name is Henrik Tolvanen, and I'm acting as a assistant professor in Tampere University in the field of energy engineering. I'll be acting as the responsible person for this course in this spring 2025. And a little bit about my background. I have worked as a university lecturer in our university for a few years, and I've been conducting a lot of master's theses, supervisions, and teaching a lot of courses related to these energy engineering topics. Since this is a new course, part of the reason behind we created this course was that I saw a lot of topics related to this energy system modeling in the master's thesis especially. So there is a need in the industry for students who are capable of solving these kinds of issues. My research background and my research, let's say the future endeavors related to my uh, tenure track are going to be related also to this energy system modeling, developing these tools, and especially the developing the sustainability related to these energy systems. So there's going to be a lot of projects related to, for example, hydrogen, carbon capture, storage, energy storage, and also about the modeling tools themselves. On this course, the learning objectives are going to be understanding the concept of these energy systems, what components you have to take into consideration when doing this modeling, and what associated parties also have to be considered. What are their roles in energy production, transmission, and consumption? And knowing different energy sources and their characteristics in relation to these energy systems. So, for example, what is the role of renewable energy versus the traditional fossil-based energy sources? And in this course, we're going to learn methods for profiling and predicting energy consumption and production. And I think mostly students are familiar with the concept of modeling this production, but we're going to also go through consumption modeling in a bit more detailed manner. Understanding the operation of energy transmission and distribution systems. For example, electricity transmission systems, but also gas networks and district heating networks are a part of these topics that we're going to cover in here. And I want the students to have the ability to analyze energy flows and energy balances in these energy systems and understand especially the role of energy storage and sectoral integration in this balance maintaining. And what is the sectoral integration? It is about utilizing, for example, excess or surplus electricity that comes from renewable electricity in other sectors, for example, the district heating networks. So if you have excess electricity that is cheap, you can use these boilers to generate heat for the district heating system. That is, in essence, sectoral integration. Then understanding the factors affecting resilience and flexibility of energy systems. So what makes an energy system flexible? What does that mean? And we're also going to touch on the resilience aspect to some extent. Being able to generate future scenarios and analyze developments and trends in energy systems. So on a large scale, on a country scale level or a city scale level, where is each system heading? How to analyze that? And of course, learning the energy system modeling process stages and being able to apply them in practice. And for this, we have, especially for this, we have a project work that we are going to be conducting with a tool called SpineOpt. Proficiency in the fundamentals of modeling energy systems. So we're going to be learning mathematical methods and computer modeling to support the design and analysis of these energy systems. So the core content is going to be understanding the energy system components and associated parties, for example, the production and storage and transmission and so forth. Energy sources and generation plants characteristics. So the biggest division in here, I think, is the fossil versus the renewable ones. So the renewable wind and solar, you have certain characteristics that you have to take into consideration and generate, for example, future forecasts. Whereas in fossil fuel-based systems, it's more of this dispatchable systems. You can produce energy or electricity whenever you have the need for it. So energy consumption and generation modeling is also going to be related to that. Operation of energy transmission and distribution systems. So as I mentioned, the electricity network, district heating network, and gas grids are examples of these transmission and distribution systems. Then we're going to go through fundamentals of modeling large energy systems. So the project work, for example, is going to cover Finland as a system. So of course, the resolution is not going to be as high as if you were to model, for example, city level system. Energy scenarios, we're going to talk about those, and the role of energy storage and sectoral integration. Additional content is going to be related to this resilience and flexibility of these energy systems. So we're going to touch on those. And of course, you are going to learn to use this spine opt in this course. So the team behind this course is going to be the following. I'm going to be the responsible person for this course. And then research scientist Justinas Jasuinas from VTT is going to be helping us with the SpineOpt. So he's going to be arranging the calculation exercises related to the project work. And Professor Anna Mutule and Diana Salos-Tiba will be from Riga Technical University. They will be giving lectures. So mostly the lectures are covered by me and also the calculation exercises, but related to this SpineOpt and larger scale energy system models, they will be covered by Justinas and Anna and Diana. And also in the background related to this SpineOpt support is going to be Niina Helistö. So if we have any problems, we'll rely on her. And then the kind of the idea of this VTT and TUNI collaboration, VTT, TUNI, and Riga Technical University collaboration came from my former student, Nelli Putkonen, who actually was working in a similar topic. It was energy system modeling in her master's thesis. The lecture times and the exercise times are mentioned here. So lectures will be on Wednesdays, and they will be held in Festia and also in Zoom. All of the lectures will be recorded, and the exercises as well. The SpineOpt related exercises are not going to be recorded, and the students will have to come into the computer class to get help with the project work. If there is some additional information that I need to distribute, most likely that is going to be a video as well. Both groups will go through the same exercises, so you can choose whichever. Seems that there is an error in the time, but it's 12 o'clock in here. And what tools are we going to be using? Microsoft Excel, PyCharm, and SpineOpt. PyCharm for that is the program that we have in our computer classes. And for the SpineOpt, we're going to provide an additional tutorial on how to install it in your computer. This is the preliminary lecture schedule. So we'll cover all of these topics. And after this, lecture package, you are going to have the time to finish the project work. So the project work will be given you in, I'm thinking it's going to be in this week, so 12th of 3rd is the lecture. So in this week, you will start going through the SpineOpt exercises. And up till that, we'll be using Excel and PyCharm. And there's also going to be a lot of AI based coding in these exercises. So coding by prompting. Related to the course grading, there are 4 submission tasks, which are 15 points each, and they account 60% of the grade, and the course project work accounts for 40%. And the project work will contain a part done with SpineUp program and a written result analysis part. The submission tasks will be handed throughout the course, and they will be returned in Moodle, and the project work will be done partially in the exercise classes, but most likely there's going to be some time that you're going to have to use on it later on as well. The course contains no exam. The evaluation will be conducted based on the project work and the submission tasks. And a little acknowledgement on VTT's behalf related to this external funding. So this project has received funding from European Climate, Infrastructure and Environment Executive Agency under the European Union's Horizon Research and Innovation Actions under grant agreement mentioned in here. And there's also a link for this MOBO project that is partially behind this course funding. All of the exercises, all of the lectures, and the project work will be provided later on into YouTube and GitHub.